Good morning, friends. This is me, Dewi. I'd like to open my presentation with full greetings for all of you. First, let's thank to God for letting us feel this day. Thank you for Miss Rivka for giving us this responsibility and also this great lesson to learn. And thank you for all my friends who giving all they can do to finish this task. And special thanks for everyone here to giving attentions and want to learn my materials. So in this case, I would like to present about articles, and the title is "The Potential of Indonesian Mangrove Forest for Global Climate Change Mitigations." So here's is the journal identity. This article is Journal of Nature Climate Change, and the title of this article is "The Potential of Indonesian Mangrove Forest for Global Climate Change Mitigations," and the authors is Daniel Murdiarso et al. And this article was published in Macmillan Publisher Limited. So let's start the presentation about mangrove. So mangrove provide a wide range of ecosystem services, including nutrient cycling, soil formations, wood productions with spawning grounds, ecotourism, and carbon storage. Given the global significance as large sinks of carbon, preventing mangrove loss would be an effective climate change adaptations and mitigation strategy. Let's talk about mangrove ecosystem carbon stock. Indonesian mangrove carbon stock are 1,083, more or less than 378 magnesium carbon. Scale up to the country level mangrove extent of 2.9 meter hectare. Indonesia's mangrove contain on average 3.40 pieces. In 3 decades, Indonesia has lost 40% of its mangrove, mainly as a result of aquaculture developments. This has resulted in annual emissions of 0.07 until 0.21 pitch carbon dioxide. Annual mangrove deforestation in Indonesia is only 6% of its total forest loss. However, if this were halted, total emission would be reduced by an amount equal to 10 until 31% of estimated annual emissions from land use sectors at present. Conservation of carbon-rich mangrove in the Indonesian archipelago should be a high priority component of strategies to mitigate climate change. So as we can see in the picture, we assess ecosystem carbon stock of 39 mangrove located in 8 sites, spanning longitudes of 105 until 140. The mangrove carbon stock were partitioned by pools, including above ground life and dead trees, below ground roots, downwood, and soil stratified into meaningful depth layers. Coupled with deforestation estimate, this allows us to use a stock exchange approach to estimate emission from land use and as well as mitigation potential. The main mangrove ecosystem carbon stock, which represent the total quantity of carbon stored in components, was 1,083, more or less than 378 magnesium carbon are Stanley propagations. 95% confidence interval indicate that Indonesia's mangrove carbon stock range between 442 magnesium carbon and 1,567 magnesium carbon in the areas studied. Estimate of Indonesian mangrove carbon stock are several times higher than those of tropical forests growing on mineral soil. For example, carbon stock of upland forests in Sumatera, Indonesia were estimated to be 254 magnesium carbon. In one of few studies to directly compare the carbon of stock of upland forest and mangrove. It was reported that average sea stock of mangrove were 830 until 1280 magnesium carbon, whereas the carbon stock of non-mangrove neotropical forests were reported to range from 141 until 571 magnesium carbon. So the Indonesian mangrove deforestation rate from 1980 to 2005 was 2,200 to 52,000 hectare, although covering less than 2% of the forest area. This was 60% of the 0.84 meter hectare annual forest loss report for Indonesia, with a total carbon storage of 3.50 each carbon. Indonesian mangrove have significant potential to contribute to climate change mitigation effort. This suggests that avoiding mangrove deforestation would reduce emissions by an amount equal to 10 until 31% of estimated annual land use emission at present. Having regional and global estimate of sea stock and emission factor help the progress of managing coastal blue carbon. Having regional and global estimate of carbon stock and emission factor help the progress of managing coastal blue carbon. However, generating country-specific estimate derived from the extensive measurement demonstrated here is an improvement uh, for the next important step for informed decisions on climate change mitigations, restorations of the great mangrove, and fishery practice. To put this into the global perspective, on the basis of our estimate, Indonesian mangrove loss contribute 42% of the global emission from the destructions of coastal ecosystem, including marshes, mangrove, and seagrasses. So here's that Indonesia could potentially gain substantial social benefits from avoiding mangrove conservation, provided that 1. The cost structure, including that of project development costs, 2. The net benefits from avoiding mangrove deforestation and conservation, and 3. Are well defined. Nevertheless, climate change mitigation by preventing the existing carbon from being released can be bundled with adaptation measures for coastal protection of rising sea levels, mitigation and adaptations. So maybe that's all about my explanations. I'm so sorry, there is a lot of mistake that I made. Maybe that's all. Thank you. Assalamualaikum warahmatullahi wabarakatuh.